Okay, so in this video, we're going to be estimating derivatives, and later on, we get to estimate the derivatives without the aid of a calculator. But for right now, we're just in this lesson going to be using the calculator to help us to estimate what the derivative is, which is a nice little feature to have. So as I pull up a TI-84 to have with me, again, if you use a different calculator, then you're going to have to figure out how to do the stuff on the calculator of that version. So I got my TI-84 there, and what we're going to do is, as I try to refer to it, is most of the features we're going to use in the calculus course, if we get to use the calculator to do fancy stuff, will be in that math button, underneath the math button in the calculator. So it's technically math, and then it's option 8. And so as I go over here, we'd go math, and then we see the option 8 there. It says the n deriv, and then little parentheses. That's basically the numerical derivative. It's basically this feature will take the derivative of the function we're dealing with and then put in the value for x that we tell to put in and give us that numerical answer. So it's not going to help you find the equation of a derivative, but it's just going to help us evaluate the derivative at an x value. So this way we can get the slope of the tangent line a lot faster, especially on more complicated problems when we get to use the calculator. So here we have this problem here. It says if f of x is equal to sine square root of x, find f prime of 2. So again, we're trying to find that slope of the tangent line. So we want to evaluate it. Again, later on, we get to do this by hand. And it would involve doing the chain rule and some other stuff. So that's why we're using the calculator. So we're going to go in here and press math option 8. And now I'm going to, as I put in there what's going in there, we're taking the derivative with respect to x. And I would say no matter what variable they're using for your equation, just always use x. It just makes it a lot easier, and less chance of any errors being in the calculator. So we'll press the x button, and then in the parentheses we get to put our function that we're dealing with. So sine square root of x, and then so let me get that caught up. So sine second square root, and then put the x inside there. Now make sure you arrow outside of that, and that's all we need. And then now we go after, and this is where it says we're evaluating it for x equal to 2. And so that's how the kind of code needs to be set up. And then we press enter. So let me find my little enter button, and boom. Whoop, let's see what I did wrong. So I probably, let's see what I did wrong. There we go. That's better. I guess I didn't hit the 2 hard enough. So this tells us that the derivative evaluated at that point of x is equal to 2, it tells us that 0.055 is what m is equal to. That's our slope. That's the slope we get to use for the tangent line. All right. Going over here to number 2, same thing. What is the derivative of the equation evaluated at 1.3? And again, here's a natural log of a fraction. And so that, again, a little bit more complicated. We get to learn how to do it by hand, but we're just going to go ahead and use the calculator feature. And so we're going to put in this code ddx of the ln of 1 over 5 minus x. And then eventually we will evaluate it where x is equal to 1.3. So let's create that. Math option 8. Go ahead and stick the x in there. Go ahead and natural log. Let's give me a fraction. And then on top, we're putting the number 1. Arrow down to the bottom. We got 5 minus x. Again, make sure we arrow outside. And then we're going to put in our 1.3 for our value. And then I'm going to go ahead and hit enter. And that tells us that this derivative evaluated at 1.3 is 0.270. Remember, you can truncate to the third decimal or round to the third decimal. Both cases, these, we didn't have to worry about rounding up, so we get to stop there. All right, I'm going to go ahead and let's see, write an equation for the tangent line. All right, so this wants us to do the whole thing. We've already found the slope of the tangent line. Now we want to write the equation of the tangent line. So we're going to do some of what we just did in problems 1 and 2. We just got to add a little bit more. So they tell me that I want to go through the x value of 1. So I'm going to also do this. I'm going to say, well, when x is 1, what's that y value that's going to be associated with it? So I'm going to quickly say y equals square root 1 over, that looks like 1 cubed plus 1. So that becomes the square root of 1 over 2. And that's really root 2 over 2 when we break things up. So root 2 over 2 is what the y value is. Again, you could use decimal there. I'm just going ahead and use that piece since it just made sense to me to use it at that time. So now let's go ahead and get into our function where we need to figure out what the slope is. So again, our slope is going to be equal to our derivative evaluated at 1. And so as we use the option here, d dx of the function square root of x over x cubed plus 1. And then we're going to evaluate it for x is equal to 1. So let's type that code in. Math option 8. And we got an x, and then now we get to do big square root, and then we get to put a fraction in there. On top, we get to put an x. On the bottom, we get to do x, and then the Q button is underneath math again. It's math 3. And then plus 1, and then let's arrow outside of that stuff. And I want to evaluate it for where x is equal to 1. So I'm going to look at it, make sure I got everything typed in the way I need it to be. Looks good. And then now we're going to hit enter. And that tells me that the slope is negative 0.17. I'm going to go ahead and round up to 7. And so now as I create the equation of the tangent line, y minus square root of 2 over 2 equals negative 0.177 times x minus 1. And again, I would just say, hey, as you're doing this, get y by itself, but don't worry about putting in slope-intercept form. And so I would just move the root 2 over 2 over. And whoopsies. And then don't worry about distributing that 0.77 or 1.177, and that's what I would focus on being my equation of the tangent line. That should keep us safe for some of the online stuff we do. All right, so let's get rid of the calculator. Let's look at the next set of problems because we're getting a table here, so we may not need the calculator as much. And we're going to give it a second here. My screen is kind of timed out a little bit on me. So again, as we're going through, we want to figure out what is there we go. We want to figure out, okay, what is, using a table, how do we come about figuring out what the slope of the tangent line is when we're given a table? First off, the function must be differentiable to estimate a derivative. We learn about that in the next lesson. This just and that basically means that it's a continuous and smooth function is what all that means when we talk about it being a differentiable. So now as we look at the table, we say, okay, we want to figure out, well, what is f prime of 3 based on what they give us here? Well, x is equal to 3 would be nestled between x is 2 and x is 4. So this is where we're going to do, in a way, the average rate of change is what we're doing here. So f of 4 minus f of 2, and that's over 4 minus 2. So that would be 10 minus 3 over 4 minus 2, which would be 7/2. And so my slope here is 7/2, or 3.5. And that's what f prime of 3 is. We again, since we don't have a function, we can't use that feature in the calculator. And so when we're given a table, we just use the average rate of change to represent the slope between the 2 points. And the key thing is picking the points that like real close to that are to what the value of the x value that we're dealing with. We don't, using 0 and 4 would be okay, but it's not going to be that good estimate. Getting a little bit closer with the 2 and the 4, that's a better estimate for what is really happening when x is equal to 3 for the slope of the tangent line. Down at the bottom, and again, we should always with I guess word problems remember to put on units. So on the top one, we would say it would be miles per hour. So we should do that. And sometimes we get out of the habit of putting that on there, but we need to put that on there because some of that's going to help us on word problems that we have to deal with in the future, narrowing down answer choices by paying attention to the units. Last one here says using the table, estimate what y prime of 100 is, show the work, lead to your answer. So again, you are very rarely allowed to just write down an answer in calculus on a free response and get credit. I mean, it really doesn't happen. Even if you wrote down the right slope but showed no work, that slope answer may be worth 1 point, but the work may be worth another 2 points. So you would get a 1 out of 3 as opposed to a 3 out of 3, even though you got the right answer, but if you didn't show any work. So that's why we're trying to show all the work on every single problem so we don't have to worry about it when we get to free response questions. And so down here, same thing. We're going to figure out, okay, 100 is somewhere right about here, between 80 and 120. So, again, we have f of 120 minus f of 80 over, it would be 120 minus 80. And that's what the slope is equal to. I don't need a little prime there. So that would be 500 minus 700. Over 120 minus 80. So that's a negative 200 over 40, which is a negative 5. Now here's the key thing with the units. It is, as we look at it, the y value is already a rate, gallons per second. So as we write our units, this would be gallons per second. And then now another per second because we divided by the x value. And that's one way to write it. Another way you can write it is negative 5 gallons per second squared. And again, it all comes from your unit analysis with your units. Well, how do we set things up? And again, the way if we just look at the units aspect, as we start the problem, it's like negative 200 gallons per second over 40 seconds. And then so now as I create this, we know it's going to be negative 5 gallons per second over seconds. Whoops, sorry, it looks like an 8 per second. And so just looking at the units, it's gallons per second. So that's G of over S times 1 over S. And that's where we get the gallons per second squared. Because that's technically saying the fraction divided by that. So then we would do keep, change, flip. And that would actually allow us to multiply the units together of the seconds. So I think it's, this is some way we will see things phrased on multiple choice problems down the road. So writing it in that fashion will come to help trigger us at times for some answer choices. So.